Have you ever actually stopped to think about who controls the electricity flowing into your home right this second? It's one of those things we totally take for granted, right? Until the moment the lights go out. But behind that simple flip of a switch is an incredibly complex, high-stakes system of power generation, distribution, and really strict financial metrics. Today, we're going to unpack exactly how that system works, who's really running the show, and how they measure success in an era of unprecedented environmental and physical threats.
Welcome to This Explainer. Today, we're diving into something that's honestly surprisingly fascinating: the SASB standards for electric utilities and power generators. Think of these standards as an electrocardiogram for the global power grid. They track its vital signs across financial, environmental, and social metrics. If you really want to understand how the electricity industry functions and how investors figure out its true value and hidden risks, well, these metrics paint the full picture.
Okay, let's dive into this. On the agenda today, first, we'll look at the two types of power markets. Second, the global sustainability challenge. Third, tracking the environmental impact. Fourth, energy affordability and access. And finally, grid resiliency and safety.
Section 1. Power markets, regulated versus unregulated.
So, in the electricity world, there are two completely distinct operational setups: regulated and unregulated markets. Now, in regulated markets, utilities basically operate as vertically integrated monopolies. This means they own the whole shebang, from the power plant generating the electricity right down to the lines delivering it to your house. In exchange for this monopoly, they have to deal with comprehensive regulatory oversight that dictates their pricing mechanisms and their allowed return on equity. On the flip side, we have unregulated or deregulated markets. Here, generating power is totally split from retail distribution. You have independent power producers, or IPPs, that generate electricity with the sole purpose of selling it into a highly competitive wholesale market. The specific financial risks a utility faces, they completely depend on which of these two worlds it operates within.
Section 2. The Sustainability Challenge. Global Pressures.
The industry standard frames this whole situation perfectly with its incredibly frank quote, "Overall, the complex task of providing reliable, accessible, low-cost power while balancing the protection of human life and the environment remains a challenge." I mean, that really hits the nail on the head. This is the shared, fundamental burden of literally every single power generator on Earth right now. It's this constant, high-wire balancing act between keeping the lights on, keeping our bills low, and, not destroying the planet in the process.
To manage that exact challenge, investors and regulators turn to the SASB standards framework, which is now under the International Sustainability Standards Board, as a sort of unified solution. It provides the specific accounting metrics you actually need to track those vital signs. These standards are what allow stakeholders to see if a utility is actually balancing that complex task effectively, or if they're secretly taking on hidden risks that could completely wreck their future cash flows.
Section 3. Environmental impact, tracking emissions.
Now, what's really interesting about this slide is that greenhouse gases aren't the only emissions utilities have to worry about. Notice these specific, highly localized, hazardous air pollutants on the list. We're talking about nitrogen oxides, sulfur oxides, particulate matter, lead, and mercury. Fuel combustion pumps these out, and they create severe health risks right in the immediate area. So the standard specifically demands that utilities track the percentage of these emissions occurring in or near densely populated urban areas. Why? Because poor air quality near a large community massively increases a utility's risk of getting hit with regulatory penalties or being forced into crazy expensive capital expenditures to install new control technology.
Beyond the air we breathe, there's the absolute existential threat of water scarcity. Electricity generation is actually one of the most water-intensive industries in the entire world. Thermoelectric power plants, so think coal, nuclear, and natural gas, require just massive, mind-boggling quantities of water solely for cooling. We're talking sometimes hundreds of millions of gallons a day. The SASB metrics literally force companies to disclose exactly how much water they withdraw and consume in regions with high or extremely high baseline water stress. This matters immensely because as community and agricultural demand for water spikes and climate change drives more intense droughts, a power plant could literally be forced to shut down if water gets too scarce. It is a massive stranded asset risk.
And of course, we absolutely cannot forget the physical waste. Legacy power sources, specifically coal, require strict tracking of hazardous byproducts like coal ash. This ash is packed with heavy metal contaminants. If it happens to leach into groundwater from inactive or active impoundments, the litigation and remediation costs can be absolutely catastrophic. So the standards track not just how much ash is generated, but the exact percentage that is safely recycled into everyday things like concrete or wallboard versus what is just permanently disposed of.
Section 4. Energy affordability, access and pricing.
This brings us to a really sobering metric, known as IFU 240A.3. It tracks the number of residential customers who get their electricity disconnected for non-payment, and crucially, the percentage of them who get reconnected within 30 days. Ensuring energy bills are actually affordable is absolutely critical for a utility's relationship with regulators. If a utility has sky-high disconnection rates, it's a huge red flag signaling deeper affordability issues, and that means regulators might push back really hard against any future request to increase rates.
But the standards also acknowledge that affordability doesn't just happen in a vacuum. Utilities are required to discuss all the external factors affecting their customers' ability to pay. We're looking at the prevailing economic conditions of the service territory, things like local poverty and employment rates. It also factors in how geography or extreme weather directly dictates energy use. Connecting these hard financial numbers back to the human context shows you exactly how vulnerable a utility's revenue stream might be if their customer base is suddenly facing severe economic or climatic headwinds.
Section 5. Grid resiliency and safety, withstanding threats.
Let's move to our final section, looking at how today's transmission lines and smart grids are facing seriously escalating physical and digital threats. The standards identify three massive disruption risks here: extreme weather events driven by climate change, natural disasters causing frequent outages, and highly sophisticated cyber attacks. And here's the ironic part. While deploying smart grid technology definitely increases efficiency and helps manage demand, it inherently provides hackers with way more entryways into critical infrastructure. So, a utility has to continually sink massive amounts of capital into fortifying against these vulnerabilities.
So, the crucial point here is how we actually measure the grid's ability to withstand all that pressure. The standards rely on specific indices like SASB and SIFI. SASB calculates the total duration, usually in minutes, of an interruption for the average customer. SIFI, on the other hand, calculates the average number of times a customer actually experiences an outage. What these metrics do is translate massive, abstract threats, like a hurricane tearing through town or a foreign cyber attack, into actual documented minutes of darkness for everyday consumers. It is literally the ultimate scorecard for reliability.
We've seen just how comprehensive this SASB framework really is. We've moved from the broad macro structures of regulated monopolies versus unregulated wholesale markets right down to the precise minutes of a neighborhood power outage. Electricity generation is a vital, totally fragile, and heavily scrutinized industry. Which leaves us with this final thought. As extreme weather events multiply and cyber threats grow more sophisticated by the day, is your local power market actually built to withstand the pressure? It's definitely something to consider the next time you flip that switch. Thank you so much for joining me for this explainer. Keep asking questions, and I'll catch you next time.